A very good evening. Hope I am audible and have shared the screen. Can someone confirm? Thank you, Anurag, for the confirmation. So I will wait for another 1 more minute and then we will get started. A very good evening. Welcome to the third session in API-driven Cloud Native Solutions course. So let me review what we were looking at in the previous session. By the way, I have uploaded these course content to MS Teams. Okay, hope you are able to access. Okay. So a change of template, they have given a new template. I will use the template from the next session. And these two PPTs which I have prepared in the old template, I will also port it to the new template. I'm just waiting for it to stabilize because they have given some 2 or 3 templates have changed since the past few days. So I'm just waiting it to stabilize. All right, then let us get started. So in the last session, we were looking at the evolution. And we are mainly concerned with the last, you can say 2010 onwards. I have not formally defined what is a cloud native app, but I have given that when we bring together Agile, which is a process methodology, DevOps, which is basically a CI/CD practice, plus microservices as the architectural style, and when we deploy the application in containers, of course on a cloud infrastructure, we can call this entire setup as a cloud native application. So this is just introducing the term. So let us look into certain important aspects because this course is about API driven cloud native solutions. So instead of just the cloud native solution, we may also encounter many times what is called as cloud enabled application, cloud based application, and cloud native application. So we will be encountering all these three different names. So let us try to understand in detail what are the differences here. The first term is cloud enabled application. Okay. So these are your typical legacy applications. Some of you may be working on mainframe applications. Okay, these are your typical legacy applications which were built maybe a few decades back, and traditionally they were built in monolithic fashion. So everything is like one block of code, and they were deployed on-prem. They use the local resources and hardware, maybe the physical servers, and these applications, they essentially cannot take much advantage of today's cloud, whatever it offers, the scalability, okay, availability, this kind of feature, because traditionally they are deployed on the on-prem. So let us take an example to understand this better. Now in this setup, so this is like a banking application, and the account information is stored within a mainframe application. So you can see this is a mainframe application where the account details are present. And coming to the front end, there is a bank teller user interface which uses a account API to access the account details. So now if we consider that this setup of the bank teller UI plus account API, this is part of a large cloud native application, meaning they are hosted on the cloud. this application and then they are making use of some cloud services, still they are connecting using the account API to the mainframe application. So this portion we can call it as cloud enabled because it is not deployed on the cloud, this application, it is still deployed on-prem, but through an API, we are able to access the features of this particular application. And if we consider the larger setup where this mainframe or legacy application becomes part of a cloud application as such, then we can call it as cloud enabled. So you can see that the word enable basically means a very loose coupling, right? So that is the word which we are giving, cloud enabled application. So traditionally this application is not on the cloud. It is locally hosted, making use of local resources. But in a larger setup where there are some cloud applications which are running, which want to interact, which want to interoperate with this particular application, we can make it available. So this setup is called cloud enabled application. So the legacy applications are example, mainframe applications. These are examples of this setup. So I'll cover the next one and then stop for any question. The second term which I'm going to introduce is cloud based. Okay, so compared to cloud enabled, the word enable means you already there's an application you are enabling, then cloud based. If we go back in time about 2 decades back, so most of the applications were developed and deployed on-prem. And now about 1 decade back, people started thinking, especially the architects, why can't we leverage the features of the cloud? Okay, because on-prem, if the scalability requirements are more, if only 1,000 users or maybe 1,000 or 1 lakh users are using your application, maybe the on-prem setup works. What if there are 1 million, 10 million or 1 billion users who are accessing the application? Then the on-prem setup may not really completely work. That is when people thought, why can't we move our application, which was hosted on-prem, we migrate it to the cloud. So this kind of applications which were built traditionally for on-prem and they did serve the purpose for some time. Now you want to move these applications on the cloud to make use or leverage the capabilities of the cloud. We call those applications as cloud-based applications. Now, what are the advantages of moving an application to the cloud? One is definitely scalability. So you can scale the application, higher availability. You will have a SLA with the cloud provider like AWS. AWS provides 99.99% availability and we don't need to maintain the servers, right? So if we are deploying our application on a EC2 instance, okay, the instance is taken care internally by AWS management. So these are some of the advantages and no need to redesign the application. If the application was on PHP or Java, J2E or .NET, we can just migrate the application onto the cloud. So what are the examples of cloud-based applications? The in-house applications, which were developed and later moved to the cloud. The benefits, we don't really need to worry much about maintaining the servers or backup. And the cloud provider will help us do that. And we also pay for what is used. So how long the application is up and running on the cloud or how much of the database we are using, we only pay for that. Scaling up and scaling down is automatically taken care. As I told, whether there are 100 users or 1 million users or 10 million users, the application SLA will allow it to support zero downtime. If we are having version 1, we want to have version 2 up and running, then the cloud provider will give us a zero downtime. We can, there are many options like Canary, Blue Green, okay, deployment options through which we can actually enable or have a zero downtime. The application will not have any downtime. The availability is high, as well as when we want to change the versions, there will be no issues in that. So this kind of application is called cloud-based. Cloud enabled and cloud based. Any questions? Or in your experiences, you have worked with any cloud enabled or cloud based? Cloud based, I am sure. If you have any application which you have ported. Yes, Amresh. Yes, I have allowed the mic.
Yes, just checking all the banking sectors and financial sector, they are still using cloud-enabled applications due to the security concerns.
Correct.
Okay, so there are two scenarios. Like one is that user face, the user what we are facing. Like let's say I'm using a phone pay or my internet banking. So that time also I'm accessing the database over internet, right?
Right.
But still it is cloud enabled, not cloud based, right?
It is cloud enabled only. You are right. It
Okay.
is not cloud based. So when we tell cloud based, the entire application rests on the cloud. So here only one portion, maybe a UI, whatever portion rests on the cloud, but rest of the application is still on-prem. Whereas if you are calling cloud based, there is nothing on-prem. Everything is on the cloud.
Got it. Thank you.
Okay. And you are right. See, banking sector has always been very conservative in moving entirely to the cloud, because way back 2004 to 2012, I have worked in the banking sector. So we did have challenges when most of the customer facing applications, they never move to cloud. Okay, they are still conservative. They will still have it on their own servers. One is a security concern mainly. So cloud based, to again reiterate, the application is now entirely on the cloud. Okay, it is not like half, I mean, some portion is on the cloud, some on-prem. Entirely it is on the cloud. Okay, but it is not built for the cloud. Okay, this is what we have to understand. This is where we come to the next term, cloud native. So cloud native is something which is built for the cloud. I will explain what do we mean by that term. Whereas if you take cloud based, something which is working well, the application, the database, everything is working well on-prem, but because of certain factors like scalability, availability, zero downtime, we are migrating from on-prem to the cloud to make use of certain features. But from ground up, they were not exactly built for the cloud. So this is the main difference. However, it is still running on the cloud itself. So having seen these two, let us come to the third definition, or I can say third term, cloud native. So as the term native, right? So we tell like I am a Bangalore native, I am a Mysore native. So we generally feel that, okay, I am born, brought up in this region. That is what I call native, right? Here also it means more or less the same. So when we tell cloud native, if you take AWS cloud or Google cloud or any of the cloud, it can even be private cloud as well. There are certain innate features of the cloud. Okay, so using these innate features of the cloud, you are developing an application. So you are designing, developing, deploying the application for cloud in the cloud. Okay, now these kind of applications are called cloud native. And in the previous slide, I showed you one of the slides, I showed you a set of, yeah. So typically we use Agile as the process methodology, CI/CD pipeline for developing and deploying the application, microservices as the architectural style, containers for the deployment, and ultimately everything is deployed on the cloud. So again, coming back to this definition, right from the requirement stage, design stage, implementation stage, testing stage, deployment stage, maintenance stage, all these stages, okay, we are basically going to do on the cloud. Okay, it is built for the cloud and deployed on the cloud. So this is what we call cloud native application, which typically uses all these. Now, one question may come to your mind when you see this architecture. Still, there are many applications which are deployed on virtual machines, right? So what if any one of the component I change? Like I will have Agile, I will have DevOps, I will have microservices, plus cloud. But what if I replace containers with VM? I will deploy my application on a VM, okay, but I'm not going to deploy on container. Or the second question may be I will have agile, DevOps, containers, cloud. This combination I will have. Instead of microservices, I will replace it with monolithic application. Okay, now can I call it as cloud native application? Okay, the answer is it can be called partial. Okay, so when we call cloud native application, it has to satisfy these 5 aspects. Okay, then we call it as a 100% cloud native application. But if any of these components are replaced, for example, instead of microservice, I will have a monolith. Okay, right from the design stage, I am thinking only of monolith. Okay, not a microservice, but other 4 components hold. Or I will not go with container. I will have these 4 components plus I will deploy on VM, not on container. Then we can call it as cloud native app, but partial cloud native app, not a 100% cloud native app. The reason is mainly from uh, if we tell 100% cloud native app, this is going to use all the features of the cloud. Okay, otherwise, if we are replacing either microservice with monolith, okay, there may be a case where we are affecting the scalability. If we are replacing container with virtual machine, okay, again, there may be instances of scalability being affected or performance being affected. So one of the non-functional requirements may be affected slightly, okay, based on what kind of application. So that way, this is one definition I want, because this is a common question. Okay. And even if you see technical papers, there are some applications which people may use some other, I can say, components instead of these 5. Okay. But they are called partial cloud native application. Full cloud native application means it uses all these 5. So now coming to the actual definition from Red Hat. Cloud native applications are a collection of small, independent, loosely coupled services. So they define it mainly from the microservices angle. VMware approach to building running application that exploit the advantage of the cloud computing delivery model. Okay, so this is very important. If we have an application with all those 5 components, then we are using the cloud computing delivery model wholly and totally. IBM cloud native application, less to where an application resides, more to how it is built and deployed. So they clearly differentiate between the cloud based and cloud native. So cloud based means the application resides in the cloud, but before that, okay, we didn't give much thought on what component should go inside that. Whereas if you take cloud native, we are telling how it is built and deployed. So building and deploying both come uh, hand in hand, unlike a cloud-based application where only it resides on the cloud, but it can earlier, I mean, during the design and building phase, we may not have taken certain factors into consideration. So cloud is about where we are computing. Cloud native is about how we are computing. So how is using all those 5 aspects. This I mentioned anyway. They are architected to run in a cloud environment, built using cloud-based technologies, accessible and scalable. This will give you a very clear picture of cloud native. This is called a cloud native technology pyramid. So you can see the bottommost layer is the infrastructure layer, which can contain Azure, AWS or Google Cloud. There are also this diagram, which means it can be a private cloud as well. You can have OpenStack, you can have your own private cloud as well. Then when it comes to the application architecture, it should be microservices based application. And when it comes to deployment, it should be container based deployment. So you can see both of them are there. And the overall process, you should have CI/CD. So you are seeing here CI/CD enabled DevOps process. Okay. And of course, when we are using CI/CD based DevOps process, behind the scenes, we are also using Agile. So Agile plus CI/CD plus microservices plus container based deployment and on the cloud. This is what we call cloud native technology pyramid. I'll just give you a moment to have a look at it. 2 more slides, then I will stop for any questions. So little bit differentiating factors between cloud native and cloud based. The focus, especially from the non-functional requirement, was totally different. If you go back about 2 decades, when cloud-based became popular, we had the application, we had to migrate to the cloud. Availability was one of the main concern, right? So instead of deploying on-prem, okay, we deploy it on cloud so that the cloud provider will ensure 99.99% availability. The application is available. The scaling, okay, will be taken care by the cloud provider. So this was the core design focus. If you take cloud native, it is all about handling failure because microservices are coming here. And if you take a traditional cloud-based application, which can be monolith, okay, one of the other differentiating factors is that cloud-based typically can be a monolith because it was developed for on-prem. Now it is migrated to cloud. Whereas if you take cloud native, it is microservices based. So it is built to handle failure. Okay. Use of microservices architecture. So the focus is not availability too much. It is more on reliability because availability is guaranteed in the cloud to a great extent. So the focus is more on reliability. We want the service to be reliable. Second is implementation wise. So in cloud based, when you are moving your application from on-prem to cloud, typically we use the VMs, virtual machines, where we have to uh, set up the hardware, the software, everything on the EC2 or whatever the virtual machine we have to set up the hardware and the software, the runtime, everything we need to have. Whereas if we are going for cloud native, they use the container images. Okay, we will come to this a little later. What is container? What are container images? But we are ultimately using container image where within the container image, we contain everything. It contains all the details about deployment. Like for example, what is the runtime? What is the code? What are the dependencies? So everything that is required for a code to work, it contains within the container image. So that way it is very fast to deploy. Let me give you an example. For any courses you are using, I mean, in my own course, you will be using the virtual lab. In the previous semesters, have you people used our virtual lab, BITS virtual lab? I'll come to your question, Anurag. Previous semesters, have you used virtual lab?
Yes.
Yes. So behind the scenes, okay, virtual lab will provide you a container kind of environment. So what happens is when you start the virtual lab, behind the scene, it will create a EC2 instance, a virtual machine. So every student is given a virtual machine, and within the virtual machine, for the particular course, like for example, for this API driven course, let's assume that Prefect ML Flow. Okay, these are the tools which are required. So they are already installed in a container image, and this container image would be installed. Okay, that is the reason when you enter into the VM, you can see Visual Studio Code, you can see Prefect, right? You can see ML Flow. All these components are pre-installed. So for every student, all these are available to you. And this is possible through the container images. So I just wanted to give you that particular example. So it is a little bit faster to deploy because everything that is required for the application to run will be stored in a container image and that will be deployed. Okay, so this is the second one. I'll just cover the next one and then stop for questions. The third one is about pricing. So if you are going for cloud-based application, it typically was more expensive because you need to own the whole stack. So in the stack, because it is monolith application, you will have the compute like J2E, .NET, okay, the actual code. Then you may need storage. It can be S3 or it can be database. You need some storage. And of course, the EC2, which is a virtual machine. You may have, Prometheus, Grafana, any of these logging services you may need. So you need to own the whole stack. Okay, and every component comes with its own pricing. So we need to pay for that. If you are taking cloud native, we only pay for what we use. Okay, now you may ask, even in cloud based, we were doing the same. Okay, one difference is there. If you are using EC2 instance, okay, the application or the EC2 instance will be running 24/7, 365 days a year. and you are paying for this particular instance, whatever you are using. If it comes to container, okay, the time when the container is running, you will only pay for that particular duration. So we will look at a few cloud native components as we go by. Okay. So when we look at those components, only the time when they are actively used, the actual usage is where you pay. The idle time you don't pay. Whereas for a EC2 instance, it may be idle. Okay. But we have to pay for the idle time. For cloud native application, we only pay for what we use, consumption based pay. We don't pay for any idle time. Okay, some examples. Okay, meanwhile, I can take questions. You can just go through this. Some examples of cloud native applications where they have built the entire application using the cloud native. Sorry, this is a cloud native application. Netflix is a popular use case. They were one of the first to embrace the microservices architecture. And way back in 2016, they shifted to cloud native development, microservices and all. And Uber is another popular example, and Airbnb. Okay, you can just go through this. Meanwhile, I can take questions. Yes, Anurag.
Yes, sir. In your slide where you are showing that, which are the key characteristics of cloud native. So let's say if I'm using in my project, I have Agile and I'm using Azure DevOps as CI/CD, then I'm also using microservice architecture, but I'm using let's say a Python code, and I'm deploying that on a PaaS environment. Okay, so
Mhm.
will that be considered as purely cloud native or partial cloud native?
Partial cloud native.
Partial.
Only when
Okay.
you use all these five which I mentioned, then it's a pure, or I can say 100% cloud native application.
Oh, got it, sir. Thank you.
Next, I'm going to show you one serverless stack, okay, which is a pure 100% cloud native application.
Okay, sir. Thank you.
Okay. Any other questions?
I mean, Lambda is fast, right? So
Yeah.
to our questions, if I'm deploying it on Lambda, it still will qualify as cloud native, isn't it?
See, Lambda is function as a service. I'll come to that. That is the next topic. Serverless computing. Okay, just if you can wait for 10 minutes, I'll give more clarity on that.
Sorry, sir. But I think, sir, Ajay's question is basically if if you're saying that PaaS does not qualify for cloud native, then what about Lambda? Right, Ajay? Is that what you are asking?
Yes, yes.
Yeah.
Okay, see
So yeah,
the
just
question. Okay, okay. The see Lambda, if you take AWS Lambda, if you take, it runs a container under the hood. Okay, it is two layered. Like for example, when you take AWS Lambda, it is using containers. Okay, and container will be deployed on some EC2 instance, which we are not aware about. But AWS Lambda essentially is a container based, I can say, service. So even if it is a kind of a pass, see, okay, the differentiating here, I'm never use the word infrastructure as a service, platform as a service, software as a service. I'm restraining myself from using those terms. Okay, I'm not using any of those terms here. Okay, or neither am I classifying any of these into those types. Like Lambda is pass, that is correct. Okay, I'm not denying the fact that Lambda is pass. I'm agreeing with that term. But uh, Lambda is basically a kind of serverless component. Okay, that is what the next topic I have is serverless component. So I'll come to, if the question is only on Lambda, I will address that next. And that comes under cloud native because I told you the five aspects. Okay, slowly the serverless computing, what we call, it is becoming the sixth aspect of cloud native applications. And that is an optional component. Okay, it is not a I can say mandatory component that I'm going to introduce next. That is the serverless computing. So AWS Lambda, which is function as a service, which itself runs on a container. So that that is the sixth component of cloud native application. So if you are using AWS Lambda for your application, okay, then definitely it is part of cloud native application. Was that the question?
Thanks. Yeah, you clarified. Thanks.
Okay. All right. So uh, I think that is down the pipeline. Okay, maybe another half an hour or so, we will come to the serverless computing. So in this, before I go to CNCF, okay, let me just add here. So I told you that a cloud native application, okay, has to satisfy these things. And in today's world, in many of the modern, IEEE transaction papers, you can see they add plus serverless computing. Okay, that means it is an optional component. Still, it is not a part of the pyramid, but slowly it is becoming one of the popular elements of a cloud native application. Okay, just I'll just go to that and then come back. Okay, because I don't want to leave the question unanswered. So I'll just go into that and then come back. So you can see here, we will be talking about AWS Lambda and serverless stack. Okay, this is what is becoming one of the hot topics today. So if you take a serverless stack, can you develop a full-fledged application, okay, using only serverless components? Yes, the answer is yes. Okay, where you will be using a compute service, you will be using a database service, you will be using a HTTP gateway service. So the microservices can be implemented using the compute service, and I'll talk about microservices in detail next. Database service, HTTP gateway. Okay, I also have a demo here. So you can use the serverless stack to implement your entire application. Okay, now is this a cloud native application? Yes. Okay, this is a cloud native application. Here we are using all the serverless components. API gateway is a serverless component. Lambda is a serverless component. Okay, and DynamoDB is a serverless component. So using this kind of architecture where all the components are serverless, this is still a cloud native application. Okay, more when we come to exactly. Okay, after some time we will come to here serverless stack. I just wanted to give you a peep. All right, so just look at any questions are there. So next we move on to cloud native computing foundation. So I told you what is a cloud native application. Now there is a foundation which is very active and who are kind of responsible for the cloud native development which is happening. The foundation is called Cloud Native Computing Foundation, which is open source. It is a part of Linux Foundation. I'll just give you the URL. You can have a look at it. So there is something interesting here. Okay, many of you may be working with many tools, okay, but you may not know that it is part of Cloud Native Foundation. So you can see here, as part of Cloud Native Foundation, there are 34 graduated projects, 37 incubating projects, 143 sandbox projects. Graduated projects means these are tested across domains, and they are actually used in live production environments. Okay, and these are certified. Okay, when we tell graduated products, they are certified from CNCF. Example is Kubernetes. So for deployment, we may be using Kubernetes. Kubernetes was the first graduated project from CNCF way back in 2017. Okay, similarly, there are incubating projects. Incubating projects means these are fully, developed, and they are now being tested across various domains or industries. We spoke about gRPC, right, in the first and second session. So gRPC is an incubating project under CNCF. Okay, let me just show the graduating projects. Most of you may uh, be aware about some of them. So these are graduated projects. Argo. Okay, this is the continuous deployment tool, Argo CD. If any of you are working on these tools, you can let me know. ETCD. So within the Kubernetes, we have this etcd component, Fluent, Flux, Helm, Istio. This is a popular service mesh application. Kubernetes, this was the first CNCF graduated project. Knative, Prometheus. So some of you may be using this for observability. So these are the graduated projects. Next is incubating projects. You can see a few of them. Generally, we see a lot of players in the same field. For example, if you take service mesh, Istio is one of the popular ones. There is a chaos mesh. Okay, many vendors who are providing these products. gRPC, okay, we looked at it in the first session. Then Kserve, okay, which is ML serving. Kubeflow, in bits we use Kubeflow. We have got a A100 server where we run our AI ML applications. And for the interface, we have got Kubeflow, okay, where we can see, how many pods are running, and then other metadata we can get. So we are using Kubeflow there. Thanos, Open Telemetry. So any of you who is using any of these projects?
The Prometheus, we got a demo in the last semester DevOps
Oh,
class.
DevOps, okay.
Yeah. So apart from that, yes, Kubernetes and the other things we are using, I mean, in bits and pieces.
Okay.
Well, to be precise, it's it's cloud partial for us, not purely cloud native.
All right. No,
I mean, we
because
have done
this is
POCs and all in
you are
our
done POCs.
yeah, but from the project, it's not that much.
All right. Because next, when you move to your dissertation, if you want to design and develop a cloud native application, okay, then you can look at these components, because you may need these components for different phases. Like as you mentioned, Prometheus, like you want a tool for monitoring, you may consider Prometheus from this setup.
So graduated project means they are more stable, right? They have more stable releases and
Yes, they are more stable releases. And the second point here, if you go to Kubernetes, okay, there are some managed services, okay, which popular cloud providers are using. For example, on Kubernetes, we have the GKE, Google Kubernetes Engine. Then we have EKS, Elastic Kubernetes Service from AWS. So on top of this open source, I can say software, we are having managed services which are provided by popular providers.
so these are free here. I mean, or because some of them have enterprise versions also. So
No, all of them are free.
okay,
All of them are free.
answer in our dissection, like we'll get the lab for doing that, or
This is something which we are discussing with the higher management.
okay.
So I am an experiential learning lead at BITS. So
Okay.
I mean, we are taking steps in various directions. So dissertation is a huge, because we get, I mean, MTech CC we get some number of students, but overall we get close to around 6,000 or 7,000 students every semester. So it is like whether we have to go program wise or we have to go like a big bang approach. Okay, these are some things which, and moreover, dissertation is always you are doing it at your company. Okay, this is what is recommended for dissertation. So if you are doing the dissertation work at your company, something which is useful to the company, and most of the times, okay, you will be using the infrastructure of your company. This is where actually till now we have refrained from giving any of these tools or making it available. Only in this space, especially for MTech EIML students, okay, we have provision where most of them are into software engineering or some other space. They may not have the infrastructure to carry out EIML experiments. Only that place, okay, sometimes we have allowed or given the infrastructure, but otherwise mostly we believe that the students have to carry out the dissertation in your own work environment.
But sir, if it's purely the expectation is to have used the office infrastructure, sometimes office and I mean as you know, based on the security policies and all, we will not be allowed to share the code, or sometimes we cannot, log in. So in that scenario, how will the dissection will go forward? I mean,
Oh, that is
uh,
not an issue. See, we do understand the security or compliance concerns. So we don't ask anything that your manager or whoever is the mentor, okay, whatever they tell that it is confidential, it should not be allowed. We don't really, I can say, stress on that. For example, in your project report, it has to be vetted out and approved by your mentor. Then only you will submit it. Okay, so you will not give any customer confidential information. The only clause here is a demonstration, and the demonstration final demo. Okay, and in the final demo, the mentor also will be there. So
okay.
apart from the final demo, there is no other way in which we ask for your code or we ask for the data to be shared. No, nowhere. That's why it is very transparent, and the ultimate decision is with the student as well as the mentor. If you feel okay, many times it has happened that you are showing us something, but something is very, very confidential. You want to mask it out. You are free to do that. You don't need to show us. You can mask it out. That is perfectly fine.
Sure, sir. Just our suggestion from our side, at least for the cloud computing batch, we should have something from an infrastructure perspective for the cloud.
Okay, I'll take it up. Okay, this time I will take it up. So most of you are in second or third sem, right? So you'll be going to dissertation
Yeah.
semester soon. Yeah, point noted. I'll take it up. So, I mean, I'm only providing an overview of the cloud native components. Okay, going further. So we already saw what is a cloud native application and the pyramid. So I don't need to talk about the cloud because you are all MTech cloud computing students. You know about the cloud. I will not again, cover the same topic. But the other aspects of the cloud native application, briefly, I will cover. One is the microservices, what we are talking here. Containers, of course, you have again in the 13th and 14th session where I will be covering container in more detail that time. So because we are going to do data science, machine learning application, we are going to deploy it on containers. So deployment comes a little later. Okay, so that is the reason why I will only give you an overview of these three now. Microservices overview, container overview, CI/CD overview. Okay, most of you may know CI/CD containers, but those of you who already know, it will be a revision. Otherwise, it will be a learning. But it is only an overview. When we go ahead and do some actual development deployment, we will learn better. So the first aspect of cloud native we are going to look at is microservices. Those of you who have done scalable services, okay, you would have covered most of it. This will be like a kind of a revision for you. So essentially, when we go to the application architecture, there are two kinds. One is a monolith architecture, as the name tells here, monolith, right? One block. So you have your entire application as one block of code. If you take any NTR application like J2E, .NET, it was typically the monolith architecture. You had the user interface layer, business layer, data layer. You may have an additional service layer and then a database layer. Okay, so your application operated as a monolith. So let me take this example, the FTGO food delivery application, which I introduced in the previous session. So here, this is very similar to the Swiggy and Zomato applications. So we know about the various clients, the courier or the delivery agent, the consumer. Suppose I am ordering masala dosa, then I am the consumer. Then of course there is a restaurant, and this is a monolith application. Let's assume that it is implemented using Java. Okay. And in the monolith application, still we go ahead with the modular development. So we identify multiple modules. Okay. These are self-explanatory. I will have a order management module, payment module, restaurant module, delivery module, notification, billing. So these are my various modules which are developed using Java language. And there is a database, MySQL, which is a relational database. So I will have an adapter through which my application talks to the database. And I may have some notification. I may need to provide some notification. So I have a adapter here, Twilio adapter, messaging service, Amazon SCS, email service, Stripe for payment. And you can note here that these are cloud services. Okay, so you may be using AWS SNS here or SES you are using. So these are all cloud services, but your application is essentially monolith. Okay, so that way, if you are deploying this entire application on the cloud, okay, if it was earlier on-prem, we can call it as a cloud-based application. So what are some of the limitations in monolith? One is a technology barrier. Because the application is developed in Java, any new person who is joining the organization, they have to be conversant with Java at various levels. Whether you are an architect, whether you are a designer, whether you are a developer, you need to be conversant with that technology. Scalability. Here the application is scaled as a whole, whether it is December 31st, okay, when maximum number of people use your application, or it is something like today evening when maybe less number of people will use your application. Okay, either way the application has to be scaled as a whole. The whole application will be scaled. Since we can't divide the components individually. Third is the size. So as the application size increases, the complexity also increases. It might become unmanageable. And it may be difficult to understand because some of you who may work in maintenance kind of projects, I worked for about 1.5 years in maintenance projects. So that time we know this application was developed over 3 years, over 4 years back, right? So as a new person who is joining the team, okay, I will be very afraid to make any changes either in the code or in the database, because whatever change I do, I don't know what kind of ripple effect it will have. Unless the architecture is documented very well, I know that, okay, if I make a change here, what are the other aspects of the application which will be changed. Otherwise, maintenance projects are little difficult. Okay. So as the complexity increases, okay, definitely it might become little unmanageable. So these are some of the disadvantages of monolith. Okay. Of course, there are some advantages as well. Okay. It's not like monolith comes with no advantages. One of the key advantage here, especially from the testing side, is that the testers, they can do end-to-end testing. I know that maybe login to my application is the starting point, logout is my end point. Okay, so I can do a end-to-end testing, and once I do the entire testing of the application, the testing team can tell, okay, that all the there are no defects. Okay, so that way that is an advantage. Okay, second is you will have a control over the entire application, because one team, if you are managing the monolith application, you will have a complete control of the application, and you will also know what are the changes that are needed. So let us contrast this with the microservices. Way back in 2006 onwards, the microservices as an architectural style gained momentum, and Netflix was one of the few companies who transitioned from monolith to microservice. So what does microservice mean? Okay. See, the term microservice, generally we first talk about a service. A service is basically a capability. For example, delivery. Okay, delivery is a capability. I can have a delivery service. I can have a shipping service, order service. Okay, so when we talk about microservice, okay, the word micro basically here means that the business capability is very limited in nature. Okay, we don't really go for a lot of business capability will fit or force into a service. Okay, the size of the service is a little micro, where every service will take care of a limited business capability. And so we can say here every microservice will focus on a single business capability. That means every service will be designed, developed, deployed autonomously. Okay, and a combination of all the microservices will make my application. So Netflix has hundreds of microservices. Similarly, you may have multiple applications with tens of microservices. Okay, now all these microservices put together is your application. So this is how the architecture looks like. The client will talk to a API gateway layer, and then the API gateway layer will route the request from the client into the appropriate microservice. Okay, so this is the generic architecture of microservice. So here the API gateway will act as a facade. Okay, generally this pattern we call it as a facade pattern, FACADE. See, traditionally, if you go to a hospital or if you go to a restaurant, or I can say hotel for lodging and staying, you typically have got a receptionist. You will talk to the receptionist. The receptionist will redirect you. If you go to a hospital or a nursing home, you will first go to the reception area where you will tell, I have come to meet so and so doctor. So they will route you to a ENT doctor or a physical surgeon, anybody for that matter. So here also it is likewise. The client cannot directly talk to a microservice for various reasons. One is the client may not know the microservice URI directly. If I am ordering food on Swiggy, I don't know what microservice I am calling. Okay, I don't need to know as a client. That is all what happens internally. Similarly, I am doing payment. I don't know which microservice is handling my payment, and I don't need to bother. All I need to do is talk to the API gateway. So API gateway will receive the client request from my mobile application. It will redirect me, or I can say a better word, route me to the appropriate microservice. And to complete the transaction, we may require other services as well. For example, if I take order is a microservice, okay, order may depend on payment service, right? Without payment, order service will not be complete. Similarly, order service may require kitchen service. Without the food being prepared, without the payment being done, my order will not be complete. So that way, there can be dependencies between the microservice. And this is where in the last sessions, we looked at 3 synchronous APIs, right? REST, GraphQL, gRPC. Each of them can be used for the inter microservice communication. Okay, so for the microservices to interact with each other, we can use any of those mechanisms: REST, GraphQL, gRPC. They are synchronous in nature, but more so we also use event-driven mechanism, publisher subscriber, which I will cover later. And there is a pattern in microservice which is called database per service pattern. Unlike the previous diagram, where for this entire application we had one database, in microservices we call it as database per service. Now when we tell database, okay, the word is generally data store. It can be a relational database or it can be a NoSQL database. Okay, so the type of database we don't mention. It is a database per service pattern. So every microservice will have its own database. Okay, now what flexibility does it give compared to the monolith limitation? I can be a Python developer, somebody can be a C# developer, somebody can be a Java developer, okay, somebody can be a PHP developer, you can be any developer, you can develop your microservice using any language. You can have any database based on your need. You can have a relational database here, you can have a NoSQL database here. If you feel you don't need any of these, you can just have a JSON file here. Okay, so that way it gives you flexibility to work with different languages, different technologies. Okay, so there is no such constraint. And even interaction between the microservice, there is a lot of freedom. Okay, you can use any mechanism. You can use RPC, you can use GraphQL, you can use REST, you can use event driven. So the architect will generally take a decision, okay, between the microservices, what kind of inter-service communication needs to be there. Okay, so all the flexibility are available in this kind of architecture. And coming to scale, you can scale these services independently. We know that order service, especially on December 31st night, okay, there will be a lot of orders for Swiggy, Zomato. So only the order microservice I will scale, of course, along with payment, whatever the related services. Now I may have another service which is called, I can say, customer order history, right? Now this service need not be scaled because on December 31st night, okay, I don't think anybody will be interested to look at the customer history. of what all I ordered previously. So that service need not be scaled. If there are hardly any requests to the service, I don't need to scale. So it gives you a kind of a freedom to scale. Okay, when I tell scale application and database here independently of the other. So different technologies, different languages I can use. I can use different scaling mechanism. And next we look at serverless computing. So I can implement my microservice using serverless technology. Okay, some microservice I can implement using general Python, C Sharp, anything. Some microservices I can implement using serverless option also. So that way they are pretty flexible in nature. This is a microservices market by 2028. Okay, it is supposed to hit 3.72 billion. And the fastest growing market is Asia Pacific, which includes India. I'll give you a moment to have a look at this slide. So this diagram I showed you some time back. So microservices architecture is API first design. Okay, so we always, when we design a service, we will always identify the API for that. Like CRUD operations, we have seen the REST API in the first session. Okay, so you can see again, I'm again repeating this. This is not a full-fledged application architecture. This is only one version in the textbook. Okay, they have actually refined this, and then you can see if you go to the textbook, the other versions. So this is a very minimalistic, kind of representation where the food delivery application can be constructed as a series of microservices, and you can also see some inter-service communication. This slide I will cover after I cover DevOps. I will come back to this. Okay, the CI/CD, these three slides I will cover after I cover DevOps. Okay, I'll come back to this. So last slide here is there is some recent shift back towards monolith. So last session, okay, one of the students actually mentioned this. So it is not like everybody is in a hurry to move from monolith to microservices for the benefit it provides. There is also the other way around. So way back in 2024, Amazon, they decided to shift their Prime video streaming service from microservices back to monolith. And they have, you can go through the articles which I have given here. They mention that they have improved the workloads, cost and scalability. So earlier, there were many microservices which used to run on independent processes. Okay, now they have moved everything into a monolith structure. They achieved a 90% reduction in the operational costs. I think over the next few years, let us see for any of these kind, okay, where people are moving back from microservice to monolith. Right now, this is one of the good examples we have. So as the years go by, let's see whether we get any more examples with evidence, of the improvement. By the way, Amazon has only moved their OTT service to monolith. The e-commerce application, okay, is still running on the microservices mode, delivery model. So next I come to serverless. Any questions here? So in this course, we don't develop any microservices as such in this course. Of course, some small data science ML experiments we will do. Just look at it here. Any questions? If everything is clear, you can just show a thumbs up sign. Yeah, thanks for the confirmation. serverless computing, have you studied in any of your previous semesters? I mean, I know you have MTech, I mean, cloud computing as a course.
Yes, sir. We got an overview in cloud computing subject in first semester
Okay,
about Lambda and all. I mean, and on job also, I mean, I have used
you have used the
Lambdas and
Lambda. All right.
functions, Azure functions.
Okay. So some MCQs I'm having here, okay, because you have already done uh, a few questions. You can just, tell the answer aloud. What is the main advantage of serverless computing? So which do you feel out of A, B, C, D?
A.
A.
A is the correct answer. Okay, any disparity or you feel anything else, okay, you can let me know. What about the second one?
It will be C.
The right answer is C here. So for a serverless stack, you need compute, database, and gateway service. So virtual machine service, okay, it is not mandatory. What about 3?
I guess B.
Correct. It serves as a compute service. What about this one? Fourth one.
Think confused with A and D.
A and D. Okay. Any other thoughts?
I guess D.
Pardon?
Last option then. Both
Last
options.
option. Okay. The actual answer is B. Okay. Let me explain the options. Okay. Why serverless deployment? See, high cost of operation, it is debatable. Okay. Compared to what? Okay. I agree on that. The A part, high cost of operation compared to what? But the second one, vendor lock-in, definitely that is a possibility. Okay. The more you are relying on the serverless, because see, serverless, we go with scale, right? So whenever you are depending on the serverless compute, either AWS Lambda or any other component, it is not just the Lambda. We have many serverless components, okay, which I'm going to introduce in the future slides. You have ECS, you have the API gateway, you have Amazon DynamoDB. So when we tell serverless, okay, there are many services. So I'm just not meaning the Lambda alone. So vendor locking is a part, okay, especially when we go with serverless stack. So when I tell stack, we know full stack, right? We may use something for front end, something for backend, database. This is a full stack application, mean, MERN, and so on. So if we are going with the serverless stack where we are tied up with AWS components, all serverless components, okay, then it becomes a case of vendor locking. Okay, so this is the possibility. Difficulty in scaling, that is not a challenge. It is the cloud providers, prerogative. They will automatically scale. The third point is not at all there. Fourth one is also not there. Complex manual configuration. We don't really need much configuration here. If you are talking about certain policy setting and all, okay, that is there. But apart from that, the fourth one is also not much of a factor. Second one is the actual factor, because apart from AWS Lambda, you have many components. And if you have developed your application using maybe 5 or more serverless components, okay, then actually the issue comes. You are unable to move to any other environment. Okay, you are dependent on a vendor. Okay, then pricing, so many other issues will start cropping up. What about the last one?
A new container created.
Perfect.
B.
B is the answer. Yeah, B is the answer. Any disparity, any other options you would feel? B is the answer. That's correct. But anyone has any other conflict of opinion? Okay, so before I move into AWS, I mean, this is for the benefit of everybody. Let me just show you some. Yeah, I think the answers are correct. Let me just show you something here. So I'm going to my AWS. I will just type Lambda. Okay, I'll show you a serverless stack application next. I'm just going to Lambda. Now, Lambda is one of the compute services from AWS. Okay, now I will create a function. Let's not worry about the function here. So you can see that they are giving you a runtime to choose from. You have Node, you have Java, .NET, Python and all, right? So they are giving you a runtime. Okay, the environment is not asking you the operating system. Okay, now, I mean, this may be very basic. Most of you may know this. I'm just repeating again. Now, if I go to same thing, so if I go to EC2, which is basically, we are creating virtual machine here. If I go to instances, if I want to launch, we already have something. Yeah.
You can confirm the region.
Yeah, I think, yeah, no, my region is correct. Asia Pacific, Tokyo only. I don't know what happened. I have deleted the, okay, doesn't matter. All I wanted to tell you is when you open a EC2, if you want to create a new EC2 machine, okay, it will ask you first to choose the guest operating system, right? It will ask you to choose the guest operating system. Okay, it will give you some images, AMI, what we call. So based on that, you can create the guest operating system. So if you contrast this with the Lambda here, okay, so Lambda is at a more, I can say, abstract level than the EC2 or the virtual machine, right? Ultimately, this Lambda will be running on some EC2 instance, which is again abstracted from us. I know the region here, Asia Pacific, Tokyo, but apart from the region, I don't know which exact EC2 instance my application is running from. So the layer of abstraction, it is asking me the runtime. So once I choose the runtime, I will write my code in any of the language I have chosen. Okay, so all I'm telling here that behind the scene, it is going to create a container for me. Okay, so AWS Lambda will create a container based on this runtime. And if I have chosen Python 3.14, whatever the dependencies are needed for this code to operate, that will be automatically installed for me. Okay, so it is like this. The Lambda function, okay, will create a container behind the scene. This container will be deployed in some EC2 instance, which is again abstracted from us. Okay, only this point I want to mention now. Now, what is this cold start we are talking about? Okay, cold start is as per AWS documentation. Suppose, let's assume now the time is 7 o'clock, right? So at 7 o'clock, somebody is calling my Lambda function. Okay, after 7 o'clock, nobody is calling my Lambda function for about 45 minutes. Okay, so after 45 minutes, the second request at 7:45 comes to my Lambda function. Then what happens is a new container will be created. This is what we call cold start. A new container will be created because there is no existing warm container. So as per AWS documentation, once a container is launched, I showed you the runtime. So once a container is launched, it will be active for 30 to 45 minutes. Okay, this is the time. So if a second request comes within that time, then the same container instance will serve the request. If it is past 45 minutes, okay, the container will no longer run. Lambda will be starting a new container. Okay, that is what we mean by cold start. Okay, that is why the second point is relevant here. I just wanted to explain this point. So function runs instantly without any delay. That is anyway the case, whether you start a new container or not. There will be some latency here. Okay, earlier if it takes, you know, 0.5 millisecond to run the experiment, it may take 1 second now. Okay, because when you start a new container, there will be some latency. Yes, please.
Sir, one of the example that OTP we are getting, that is also part of Lambda, if I'm not wrong.
OTP, right? Yeah,
Yeah,
definitely.
the bank while login,
The
we are
bank,
getting OTP
yeah, the
application.
bank OTPs, they could
Yes.
be implemented because today most of the core banking functions, like especially Punjab National Bank and State Bank of India, everybody is using core banking today, and notifications especially they can be definitely implemented using Lambda functions. One of the classic examples, correct? So I think these MCQs I just wanted to give. Okay, now most of you are clear. I don't need to go too much into it. So when we tell serverless, the main point here is that the layer of abstraction we are increasing. Okay, if I come here, see physical infrastructure. If I want to talk about SaaS, IaaS, PaaS, and SaaS, so physical infrastructure is taken care of. Some virtual machine which is deployed in some region. Okay, I'm not going to bother about it. The cloud provider will take care. Compute is taken care of, right? I'm choosing maybe Python runtime or Java runtime. Okay, so that is taken care of. Storage and databases, messaging orchestration. So all we are telling is that these components are managed by AWS. Okay, all we need to take care is the logic. So suppose I'm using Python, I have to write the logic in Python. Okay, so when I tell storage and databases, okay, this could be serverless components like AWS DynamoDB, and database, yeah, database is DynamoDB. Storage S3, Amazon S3 is also a serverless component. Okay, so compute is AWS Lambda. So all these things are taken care by AWS. Okay, all we need to do is write the code. So this is one of the, like you mentioned, one of the classic example now is the notification what we receive from bank. So another classic example is the image resize example. So suppose many of the times all of us face this issue that I have a passport size photo which is 2 MB. Now passport website, some website is asking me to upload my photo resized. Okay, it has to be less than 100 KB. They are telling me. So this 2 MB I have to resize to less than 100 KB. So I can develop a simple serverless function. So my input source, that 2 MB photo, I can put it into S3 bucket. Again, this is a complete serverless application. So this will trigger the Lambda function. This is where I can write my logic for resizing using any programming language I want. So whenever anybody uploads their image, automatically it will trigger the Lambda function. So here I have written my code in some language for the resize compression, I can say. And once the image is resized to less than 100 KB or something, that new image is now output into another S3 bucket from which the end user can download this resized image. So this is another application. So from the AWS world, we have Lambda. From Google Cloud, we have Google Cloud Function called GCF. Azure, we call Azure Functions. So these are all examples of function as a service. In the AWS world, I am showing you the serverless services. So the ones which we know of mostly data store, S3 is serverless, Amazon Aurora, okay, this is RDS, that is relational database, DynamoDB, which is NoSQL database, and compute AWS Lambda, which we know. Then we have Fargate. So Fargate, especially when you want to deploy containers, EKS, ECS and all, we can use the serverless function Fargate. Even in integration, we have many. Amazon API Gateway, SQS, which is simple queue service. Okay, many of you may have used Kafka, okay, as a message broker component. So SQS is also one of them, which can be used for queuing purpose. Then SNS for notification, simple notification service. So you have an email, you can give an email, And when this particular event happens, you are going to send the notification for a set of emails. AWS step functions, especially in microservices application, uh, distributed transaction is a challenge, or I can say it is very complex distributed transactions. So one of the way in which we can handle distributed transaction in microservices is using AWS step function, okay, which is a serverless component, then AWS app sync. Okay, so these are some of the even event bridge. Okay, and it is not that this is comprehensive. So every few months new serverless components are added. The only thing to remember is that they are managed end to end. Suppose AWS Lambda new version comes, AWS will automatically upgrade it to the new version. So all we need to do is write the code, and not only code, have the data, whatever the component does. Okay, we have to just take care of the logic. Everything else the AWS will take care. I'll give you a moment to have a look at it. So next is serverless stack. Using one or more of these components, can we build applications? Just like we have full stack, right? Mean stack, burn stack, okay, XAMPP, LAMP, WAMP. So these are all full stack examples. Similarly, can I develop an application using only serverless functions? Okay, or serverless components rather? The answer is yes. And that is what we call serverless stack. Okay, I'll come to that and go back. So you can have a compute, the minimum requirement here is for a compute service. Database service may be required or not, like the example I showed you here. We don't require a database service. Okay, you require, okay, data service you require in a way, yes, S3 is a data service. So you have this data service, you have the compute service, right? So you can use one or more of these compute service, data service. And if it is a web-based application, you can have a HTTP gateway service. That will be your serverless stack. Any questions here?
Is it possible that we can host a web page using Lambda functions?
Host a web page? Generally, no. What we do is we have what is called a crowd front. See, web page is basically a static component, right? Okay, I think uh, just a moment. Okay, you may want to redirect from the Lambda. I'm not getting the question.
No, assume that if we are planning to build a website using serverless only, is it
Correct.
possible to have a web page being hosted by a Lambda function? I mean, if somebody hit a HTTP on particular URI, it then invoke a Lambda function to show us a web page.
That is possible because directly from the API gateway, okay, we can invoke the Lambda through HTTP. That is possible. But somewhere I think I'm not sure about whether the, because web page is HTML ultimately. So whether that logic can be embedded, I'm not sure about it. Okay, I'm not getting that function name, right? Generally,
Sir,
the static files. Yeah, go on.
So, but is Lambda made to host? I mean, is it that prime? I mean, is hosting a website a primary
No,
for Lambda? So I see
no.
it can. I think it can be done, but should it be done is the question actually that way, because there are better ways of hosting.
Right. So Lambda, see, basically every component that we have here comes with its own best practices and what is possible, what is not possible. So the answer is like whether it can be done. Yes, it can be done. But, you know, There are better ways to do it. Okay, I think that will be the answer for that, because when we look at Lambda function, okay, we use it for uh, writing some logic. Like for example, we saw the previous one. Okay, one example, you can write logic to compress the images, and I'm going to show you one demo here where I'm using it basically for logic to connect to the database and then give the result back to the API gateway. But whether you want to write your web page logic inside, okay, I don't think that is the right use case for Lambda.
I was assuming actually, I was assuming that if we can host a static page on S3 storage, which we can map to a URL and offer to end user, as soon as he clicks on any button on that particular static web page, it invoke a Lambda function and then might store a file.
Yeah, that is possible.
was-
So you can see that the Lambda function can be called by more than 300 plus AWS services. Okay, so there are 300 plus ways in which you can invoke the AWS Lambda. So that way, yes, you can use a URI to call it. I don't think that is an issue, if that was the question. So from the Lambda, you can connect to S3. From Lambda, you can, call any other service you want. If Lambda, the purpose is it's not implementing any logic, but it is only calling some other service to carry on and do some logic. Many times we may use Lambda for initial authentication or security purpose also.
Okay, thank you, sir.
Okay. So I will just give you one small demo of a serverless application. So this is what this application does. In the first class, I had showed you one application where we had the user, okay, I think bookstore application where we had books which was written using fast API. Okay, the same application, instead of book, I am calling it as a user. So the user data is stored in Amazon DynamoDB, which is a serverless application. And there is a get, okay, and then there is a post. There are two AWS Lambda function. So get basically gets the data from the DynamoDB. Okay, so this is the root, the client, which can be Fiddler or it can be a curl or it can be, uh, any component. It will call HTTP request to the API gateway. API gateway, based on whether it's a get or post, it will invoke the Lambda function. If it is get, it will get all the details and route back. If it is post, a new user data is added. Okay, so this is a simple application, which is a full stack, or I can say serverless stack based application. So let me show the components here. First, I will show the Amazon DynamoDB. So this is a NoSQL database. So I have a users table. Let me just delete this. So you can see it contains address, email, mobile, name. Okay, and there are some values. Okay, it's a very simple table. It contains this data. Okay, so this is my DynamoDB. Now I will show you the logic for AWS Lambda. The function is called getUsers. So this is the code. So initially import JSON because the request and the response both are JSON, and I'm using Boto3. So this is the Python SDK for AWS, meaning if you want your code to interact with any of the AWS services, like in this case, I want to talk to DynamoDB database, then I can use Boto3 because my language is Python. Okay, if you are using C#, Java or any other language, you have to use the appropriate SDK. Okay, for AWS. Since I'm using Python, I'm going with Boto3 framework. Okay, so this is my function handler. So the first statement is very simple, boto3.resource DynamoDB, because I want to connect to DynamoDB. I get that particular object. So within DynamoDB, I am interested in the users database, which I showed you some time back. And we have a function called scan. Okay, so when I do table user.scan, I will be able to iterate through the rows. So I showed you that there are 4 rows here. So I'll be able to iterate through the rows, and then I will collect the data in response variable. So when I call response of items, it will give me the value, and I am putting everything into the body, and I am returning the JSON object. Okay, status code 200 if everything goes well, and response of items. Okay, I am just returning this. So this in this code, I am going to talk to DynamoDB database and get the data from users and then return back. So let us test this out.
How's the authentication happening in this case?
No authentication. It is a very simple example. So as I told, I mean, I'm going to show authentication a little later. When we come to 5th session, I will demonstrate authentication. Okay, till that time, no authentication. So you can see the response. Yes.
But sir,
What about the table name, sir?
No, I didn't get it.
How come it's allowing you to interact with DynamoDB directly?
Oh, okay. What you are asking is about the policy and permissions, right?
No, sir, like if you have a DynamoDB, right, if some schema is there, schema
Right,
ownership
right.
is there, all.
Right. So those things I have set up in the IAM roles.
Okay.
Okay, so see the connection between the Lambda function and the DynamoDB database. Okay, because we have to give the permissions for usage, right? Whether I want to add anything or I want to retrieve the data, so I need to give the permissions. Okay, for DynamoDB that has already been set in the IAM. So this is the response I am getting. I mean, that's a good question. So this is the code. And once you deploy the code, okay, this will be working. And I will show you the API gateway, the first part of this. So here, as per the diagram, you can see that the API gateway has got get option, has got post option. So my API gateway, I'm calling user. They have got a get option, post option. If I click on get, you can see it is talking to the get users function. And if I go to stages here, it will give me the URL. So I can directly invoke the URL. Okay. And you can see my response. So when I click on the URL in the API gateway, this activity is happening. From the URL, HTTP request is sent to the API gateway. Then I'm invoking the get users function. It is talking to the users database, getting the result and returning back. Okay, so this path I demonstrated. Next is the post. So first I will go to the Lambda function. Add user is the Lambda name. You can see the logic is very similar. The only difference here is that from the HTTP request, we will get the JSON object, right? So I want to add a new user, meaning I want to give these details. For example, address, email, mobile, name. I want to give these details. So you can see event of ID. This will give my ID, name, email, address, mobile. This data I have to capture from the input request, and then I am going to use put item. So this is a function which there we use the scan to get. So here I am using put item. I am going to construct my item object. Okay. And when I do table users dot put item, okay, this item object will be put into the database. And I have got return status code 200 information, inserted the information successfully. If there is any issue here, I am using a try except block. So I can go to test here. Only thing is I have to give the key value pair. Okay, I will use the API gateway to give the request. So if I go to the API gateway, now it is post. Let me go to the previous one. This is the post. You can see the post, it is talking to put add user, which I showed just now. Then I have got my URL, okay, but I cannot call it directly. I can use Fiddler because I need to pass the HTTP request parameters. So I'm going to do a post here. Okay. And I need to give my request body. Let me see what are the fields I have here. Something which is not there. There is no particular order. I hope this works. Let me just try it out. So let us check whether the information which we have just given, will it work? I'm just going to the get function. Yeah, it did insert. So NSP, you can see here the one which I just gave some time back, right? Mobile address, ID, email, and name. Okay, so it has inserted. So I just wanted to show you a very simple serverless stack application where when we call it as a serverless stack, okay, it uses all the serverless components only. Compute, database, gateway, okay, and there are multiple options at various levels. Okay, as we saw in the previous slide, you have multiple options here. Compute, data stores, integration. So this is becoming a very important, serverless stacks are gaining prominence in the last few years. Drawbacks, I covered that. Yeah. So I will stop for any questions.
Sir, when this will be available, I mean, to test this in the lab?
Okay, testing in the labs. See, serverless, I just gave you a demo. Okay, we will be doing a lot of experiments in data science, AIML, and data science and AIML. Okay, so this is a pure, I can say, application because in this course we are mainly focusing on data science and AIML. So those applications you can work in the lab. Okay, this is just a demo from my side. And if you really want to experiment with the code, I can provide. That is not a issue, but I had not planned it. Even in the earlier semesters, we mainly do the experiments for data science and AIML. Okay, we have a lot of experiments there.
If you have that code, sir, can you give us, I mean, just in case you try it?
Yeah, that I can. I will share. Okay, any other question? So next we move to another aspect of cloud native application, which is DevOps. So CI/CD is an integral part of cloud native application. So first of all, what is the CI/CD? Many of you will be aware about it. Anyway, let me just give a brief for this. So when Agile came into picture way back in the early 2000s, it bridged the gap between business and development teams. Okay, because way back 2003, 2004, we were working in a non-agile environment. So we know the issues that time. Waterfall model. Okay, the customer thinks something, developer thinks something, tester thinks something else. Right, this was a very big problem. So Agile solved this to a great extent, where the business and the development team are in sync. You may have weekly meeting or a daily meeting, and the requirements, they are not that huge. Okay, like in one of the projects, it was almost we captured the requirements for 1.5 years. It didn't even see the design stage. Okay, the project got shelved way back in 2004. So now it is not like that. Requirements, typically in Agile, you capture it in every sprint. You have to have a deliverable, and requirements are captured in smaller formats so that you can see quick deliverables. So that way Agile fixed, or I can say improved, the communication and collaboration between the business and development team. But this part, okay, because ultimately when the application is deployed and the end users use the application, that is what is the actual ROI, return on investment. So this was the wall of conflict, the communication, collaboration between the development and the ops team. So this has improved with the DevOps. So Agile fixes this part, DevOps fixes this part, as the name tells, Dev plus Ops. So put together, Agile and DevOps, it will make the release of the software, okay, very smooth. And earlier we had seen one diagram sometime back, where I showed you that Amazon on a daily basis, they do something like 10,000 micro deployments a day. Okay, so those things are possible only when the end-to-end communication and collaboration between various teams is very smooth. So the traditional definition is alignment of IT, development and operations. Microsoft, I like this definition better. Union of people, process and products to enable continuous delivery of value to the customer. So they emphasis on 3P: people, process, product. So ultimately it's a culture. Even if one team will refuse to be a part of CI/CD, or they actively take care, okay, then everything will go haywire. So it is a culture. The organization, the teams have to adopt it. Second, at the end of the day, it is a process, or it's a methodology. Okay, tools will only enable CI/CD, but ultimately, if somebody asks what is DevOps, it is a methodology. You have a sequence of steps. If done correctly, okay, then there will be a faster release of product to the customer. So it is a methodology, which is process. To facilitate the methodology, we have some tools which can be called products. So this is the overall DevOps lifecycle: plan, code, build, test, release, deploy, operate, monitor. This is a nice diagram. So at every stage, we have multiple set of tools, okay, which can aid in these activities. So typically, while we are doing planning, we may use, okay, certain tools like Jira for planning phase. Code, definitely we have version control. Okay, today Git. Okay, you may also use any other tools, but Git is a good version control code tool which you can use. Source code, of course, it depends on which language you are implementing. You have various IDs in which you can develop the source code. Then comes the build phase, okay, where the development, whatever the developer is developing the code, it will be committed and then it will be merged with the main main code. And next is the testing phase, okay, where unit tests, integration tests can be carried out in the project. Then release. This is the actual, the end of CI process. That is a continuous. So this phase is basically the continuous integration. And next comes the continuous delivery or deployment. So deploy, we have to deploy it on the resources. So where we can provision the resources. Configuration management is an important part here. When it comes to operate, okay, we have to deploy it somewhere. So we have spoken about virtualization, containerization, they come here. Last is monitoring. So whatever applications we are having, whatever the resources, infrastructure we are having, continuously we need to monitor that, and that is where logging comes in handy. So this is the overall big picture of the DevOps lifecycle and the various stages. I had one on the, no, I don't have on the tools. So for every stage, you have a couple of tools. For example, as I mentioned, version control, Git is a tool. Then automation. Okay, if you are going for, you may have Selenium as one of your tool. Then for the entire CI/CD, okay, you may use the AWS tools what you have, AWS deploy or AWS, code pipeline you can use if you are in AWS, or for CI you can use GitHub Actions. For CD you can use Argo CD. So there are plethora of options or tools which you can use for any of these phases. Infrastructure as a code, Terraform is available. Okay, and there are other options also within the AWS world. Cloud Formation is there, SAM is there, serverless application model, many are there. Then configuration management, you have Ansible. Virtualization, we have seen EC2, containerization. Logging, we discussed some time back. Okay, you have many options for logging and monitoring. For example, Prometheus. Okay, for visualization, you can use Grafana. And AWS world, they give you the AWS CloudWatch, okay, which is good for, it is tied at every service level so that you can monitor the services. So within DevOps, we have a set of, see, ultimately DevOps is a methodology, what we see here, this big picture. So within this, we have multiple core practices. So the core practices are CI, which stands for continuous integration, CD, continuous delivery / deployment, CM, continuous monitoring. Okay, so largely CI, continuous integration, CD, continuous deployment, delivery / deployment. There is some small difference between them, the term delivery and deployment. And lastly, continuous CM, continuous monitoring. So this captures the CI/CD largely. So in CI, what happens? Okay, I am a developer, I am doing some code changes. So typically I will create a new feature branch. Okay, I will create a new feature branch and then I will do my changes. Okay, then I will go for the build. So I may use any CI tool, which is a continuous integration tool, where I will build my tool and it will integrate it with my changes basically, and I can run some unit tests along the way. Okay, I can write unit tests which will be executed, and if everything goes well, okay, my build, okay, or I think instead of this, this is a better one. So I have a source code, source control, which is like Git. So the developer will check out the code and I will have my own feature branch where I will do my code. Then the developer will commit the changes. When the developer commit the changes, there will be a CI server like GitHub Actions, okay, or Jenkins, GitHub Actions. You can take any CI server, continuous integration server. You may use any mechanism for build if you are in Java world or .NET or Python. Okay, you will use it to build the application with the changes which the developer has done. And once the changes are done, the build can result in two outcomes. There will be a build failure. If there is any build failure, developer will be notified of the failure so that they can rectify and this process can be restarted. If the build is successful, the clean build, okay, then we go into the unit and integration testing stage. Okay, first is only the build, like whatever code changes I have done, whether I will be able to build it. Okay, once that is success, the code goes through the unit and integration testing. Again, there are two outcomes. If there are any failures or if everything is successful, the developer is notified of the test results. So this is basically the CI or continuous integration workflow. So once this stage is done, we come to the continuous delivery / deployment. There is only one difference between them. See, ultimately, when we talk about delivery or deployment, it is going into production. So in this stage, we are in the development environment. Then we deploy the code to the staging environment. In the continuous delivery / deployment, we move the code into the production environment. The main difference between continuous delivery and deployment is the way the approval is done. In continuous delivery, there will be a manual approval once all the tests are done, okay, like unit tests, integration tests, acceptance tests. There will be a human in the loop where manual approval has to be given for this code to move into production. Whereas if you are taking continuous deployment, once the acceptance tests are done, there is no manual intervention. Automatically, once everything is successful, the code will be deployed to production. Now I want to hear from you in your organization, which of the two mechanisms you use. Once the acceptance tests are done, okay, will there be a manual approval before moving into production, or is it automated?
For me, it's manual. So still, so the sequence is like the dev work is done. Then after it is going for testing. Then after that it is going for peer review, and then after that it is going for production deployment. But post peer review, we need to manually deploy in the production. So it is manual in my organization.
So it is a continuous delivery.
Yep.
What about the others?
It's the same manual only.
Manual
Motion.
approval.
Yeah.
Okay. So the term CD stands for continuous delivery / deployment. So in your case, it is continuous integration and continuous delivery. So manual approval is required before
So,
the code moves. Yes, please.
can you go back to that? Yeah, sir. So I'm 100% sure it's, for me, it's manual, but in one of the projects, so when you say acceptance test and then automated, right? So when the test passes, which will be automated, right? It automatically gives, like Azure DevOps will automatically gives the approval and deploys it into the production, right? That's what you are saying in this, right? In the deployment.
Correct.
Okay, because in one of the projects, acceptance test was automated for me, but then it went to the the architect, and he used to approve it, and then it used to deploy automatically. So will that be a second
No,
continuous
then it will be this only, continuous delivery only.
delivery, right?
If
Oh,
there is
okay.
a human in the loop,
Okay, got it.
okay, then it is continuous delivery. See, I agree, most of these stages are automated. Okay, even acceptance tests, okay, unit tests, everything is automated. I do agree on that. The only thing is, after the acceptance tests are completed, there is no human in the loop. Automatically, okay, the image or whatever we are working with, okay, that is automatically deployed to production
Yes.
with no manual consent. Okay, I can add that word.
Okay, sir. Thank you.
Okay, in the last 2 years since I have designed this course, when I interact with most of the students, okay, not only non-specific, even in companies like Airbus, SAP, most of them have told me that it is manual approval. Okay, I'm yet to hear, okay, anybody going for automated deployment.
Even I have not seen, sir.
No, no,
I
no.
was asking the next question, where did you see this?
No, no, no. I am yet to see. I mean, this is what, uh, if it is a very small application, I am not sure, okay, whether they feel that there should be a human, but 99% of the time, see, it is not just a simple approval, right? You have to take into consideration multiple factors. So that way, human in the loop is always required. Even if we go in the next few classes, we look more into data science and AI/ML. Okay, we will be doing the experiments definitely, but if we want to put it into production, okay, definitely there has to be a human in the loop. Even most of the AI projects today also, they will have a human in the loop before it is put into production. Now coming to the team formation, I think this is the last slide before GitOps. So traditionally, okay, traditionally meaning most of us may still go with this, but in the DevOps, kind of organization, this is preferred. So you have a overall project. Okay, the team will now consist of people with different expertise. Okay, now you may have an architect, you may have a developer, you may have a quality assurance engineer. Now all of them will be working in the same team. If you go back a few years in the traditional organizational structure, for a particular project to be executed, okay, you would have a separate development team, you would have a separate quality team, you would have a separate operations team. So it's something like development team will take some X amount of time, they will develop. Then the code will move into the, for the quality team, they will test in their environment, and then it comes to the operation team. Okay. And one more thing here, okay, the team itself, the team formation, you have a separate operations team. Now these guys will be handling maybe some 10 or 15 projects. Similarly, development team, similarly the quality team. Okay, today's DevOps organization, within the same team structure, you would have all the skills put together. So that you are working on one microservice, let's assume maybe a shipping microservice. So there is a developer who will develop the code for the service. There is a quality assurance guy who will check the particular service. And then there could be any other person who would actually work in this particular project. Ultimately, this team is responsible for the design, development, deployment of that particular service. Okay, so this is the DevOps organizational model. So you can comment on what is the organizational model in your companies or in your projects. Of course, there are some roles which are, still horizontal, I can say. For example, architect. Okay, architect may be seeing multiple teams. Okay, even if you take something like a DevOps engineer, a DevOps engineer will not be tied to a single team. A DevOps engineer is also a horizontal role where they take care of the DevOps implementation for the entire project. All right. So we just have one more small topic, GitOps. So as you see here, okay, the DevOps, right? The dev term is replaced with GitOps. Okay, so before I explain any of this, any common observation what this could be?
Development oriented towards Git.
Development oriented towards Git. Okay, that is right. So Git is the single source of truth. Okay, for your source code or for your application, it is a single source of truth. Okay, that is one part that is correct. There are two other definitions which I want to add. So one is we are using Git for managing the application. So your source code rests within the Git. That's why we are calling GitOps. Okay. The second is not only your source code, the infrastructure portion is also stored in Git. Okay. So this is the second. One is the managing your application or source code. Second is the infrastructure configuration. I'll come to what this means. Okay. The third point is that it is declarative in nature. Okay. There are two things, procedural and declarative. If you call it as GitOps, okay, you are taking care of the application source code, infrastructure code, as well as declarative. This is important from multiple standpoints, especially when we look at data science and ML applications. Okay, we would look at infrastructure configurations being written. So instead of explaining it, I will give you a video. Anyway, we have about 4 minutes time. So you can take time and look at this wonderful video where they have explained GitOps. I will not play it out here because video will not be, heard by you, but you can take the next 10 minutes. Okay. Anyway, the time is 5 minutes and you can have a look at video. I will be on mute. Yes, Amresh.
Sir, I have one doubt throughout this video and from my current experience also. So, as dev work is completed, and like I'm just giving example in my scenario, dev work is completed. Then after that, they send for tester to testing. Then after that, tester submit the report. Then after that, dev send a dev raise a PR request, and once that PR is get approved, they merge that code to main or master branch. Then post that, they deploy they attend that cab meeting and deploy to production environment. But is it a right sequence that every time first post their work should we go to tester, or we can suggest that post it is going to tester. Once their work is done, it should be go to they should raise a PR request. It should be get it reviewed first from other developer or peer developers. Then after that, it should be get to go. It should tested by the tester.
See, the peer development, it depends from company to company. Okay, so it is not a mandatory step, the peer development. In the video, did she mention about peer? That's where the question came from.
Yes. Yeah.
Okay, that is not a mandatory step. I think it's taken from a very general perspective. So peer review is not mandatory. Some companies have that, some may not. Okay, but whatever the set of steps what you told, it is correct. The only thing I would like to add in GitOps is the second part, right? So as a developer, the continuous integration, the build part, the merging with the main source code, the testing, that is correct. But what about the next phases? Right? That is what the GitOps mainly talks about. So your source code will be in the Git repository, that is correct. But along with the source code, okay, there is also a manifest.yaml file, okay, which will contain details about your deployment, like how many pods need to be created, okay, how many, what are the container specifications. So this file or this source code, which we call YAML file, will also be in Git. Okay, this is what I'll be explaining. I think in this video, she has already covered that, but I'll be explaining this more in the next class. So along with the application code in the Git, you will also have configuration management in the Git and infrastructure as code in the Git. Okay, so this is what GitOps basically means, that all these source code files will be in Git repository. Okay, then we will look at additional details also. All right, so it's almost time. All of you please complete watching this video. I will cover more about GitOps in the next class.
Thank you, sir.
Okay, then. Thank you all.
Thank you, sir.
Thank you, sir.